Welcome to the latest installment in the TOSCA Implementer Series. We are pleased to present Using TOSCA, Unfurl, and GitOps to simplify application deployment. Just a couple quick notes. Obviously, this session is being recorded. We will hold questions until the end, and please feel free to type those questions in at any point by either using the Q&A box or the chat. We'll be tracking both. And it is my pleasure today to introduce Adam Souzas. Adam is the co-founder of One Commons and the creator of Unfurl. Over the years, he's helped found several startups and open source projects, including Connecta, StyleMob, Rhizome, and Vesper. We will close the session today after your questions with remarks by Chris Lowers. He's the CEO of Ubicity and the chair of the TOSCA Technical Committee. And with that, I will turn it over to you, Adam. Thank you very much.
Thank you, Dee, and hello, everyone out there on Zoom. So I'm going to talk about Unfurl, which is a new open source implementation of TOSCA that I've been working on. So what is Unfurl? So Unfurl it's a TOSCA orchestrator that fundamentally does two things. One, it deploys your applications. It, in a way, since we're using TOSCA, it can be cloud independent of your infrastructure, so you can create abstractions around your cloud infrastructure. And then it manages your deployments, including things like the configuration, the artifacts, the history and state, and it manages that all in Git. And so a little bit of history. So basically, this started a couple years ago, is really me scratching a personal itch where, if you work for a big company, if you have experience with DevOps, you can rely on this big infrastructure, complicated infrastructure for building a DevOps pipeline. But if you're, I'm doing a smaller company, like I've done a bunch of little startups over the years, or just personal projects as a developer, it's really hard to keep track of your deployments, being able to reproduce it, shut things down, start it again, archiving it. So those kind of needs were just not out there. So I started to build Unfurl around that, and I really just wanted everything to be stored in Git to have this kind of archiving. And I started building it and designing a YAML vocabulary and thinking a lot, experimenting with what's the semantics you need to do this, enabling this. And then about 6 months into it, I discovered TOSCA, and I had only been briefly aware of TOSCA before. I kind of remembered it as this XML vocabulary or something that was complicated, and so I didn't ignore it. But then I discovered they had the YAML vocabulary. TOSCA 1.3 really ended up looking a lot like what I already started developing. So I was like, well, why build my own custom language when I could use TOSCA? So I ripped out what I did and started implementing TOSCA, implementing the vocabulary, and then I ended up emailing the mailing list, and then Chris invited me to join the technical committee. So now I'm really involved with TOSCA. So that was exciting, and so this thing that started out as like a personal project, and kind of an experimentation, really evolved into something which is this bigger One Commons project. And now it's a company that I started, which is really based around this idea of how can we create cloud services that really have a lot of the same characteristics that we see with open source and open source software. We see how open source software at the infrastructure level has really come to dominate as a dominant way to develop software. Can we do the same thing with actual cloud services? And so basically what that means is, can we build cloud services that are transparent in the same way open source code is, reproducible, just like I can clone source code that's in Git and rebuild my own copy, shareable in that same way, and then decentralized and be location dependent. And so this idea of these vision of what we call open cloud services has really evolved from what Unfurl is, and Unfurl is now the core component for developing this. And so obviously it's a big long-term project, but just here we are. And so that's the history. And so I think the easiest way to think about Unfurl and what it works is to really, especially if you're a developer, you compare it to this, how you build systems for building an application or building an executable. The kind of classic model for that is, you have your source code files, and then you have a tool, classic one is called make. And what make does is it looks at the files on your disk and figures out what's changed and what needs to be built, and then it invokes, the compiler, the linker, and then at the end you get your application. So what if we apply that same approach to actually your cloud infrastructure? And that's what Unfurl does. So Unfurl looks at all the inputs and processes you need to deploy your cloud infrastructure and provision it, like your container images, infrastructure of code, all the configuration files. And it looks at that and then builds up a plan, and that's where Tosca comes in, and then it invokes the tools that you need, whether it's Terraform, for infrastructure as code, or Ansible, or just command line tools and shell scripts. It'll invoke those tools and then build your cloud infrastructure and keep track of that and keep track of the changes you made, so that when you go to redeploy, it'll figure out what else needs to be changed and deployed. And so you can think of Unfurl as a build system for your cloud. And so why do you need that? And the reality is there's really no DevOps tool that does everything for you. If you look at the classic CI/CD flow and DevOps flow, there's these different stages, there's different things. You have to package it up, build the container images, you're provisioning it with something like Terraform. There's day 2 operations, and maybe you use Ansible or scripts or something like Chef for that. You have a continuous integration system, which is a CI/CD, but there's no tool that does it all. And so having a build tool that knows which ones to call enables us to have a nice, clean way to manage your DevOps infrastructure. And so to that effect, Unfurl works hard to integrate the most popular DevOps tools. So it has fairly tight integration with Terraform, with Ansible. It understands Kubernetes, it understands Docker. It can use other libraries, like OctaDNS is a library that supports almost all the external DNS providers out there. It can support things for local development like Supervisor D, which is a very, very lightweight process manager. So it has a bunch of out-of-box support, but it's using a plugin system for all these implementations. So it's easy for you to implement your own and add your own. You can do either in the YAML file or writing a Python API. And so why Tosca? And why do we end up, like I said, ripping out what I was doing and rebuilding it using Tosca? Well, Tosca provides the language and the vocabulary that we need to describe all these relationships to create this build system we're describing. So Tosca lets you describe artifacts. It lets you describe the actual resources that you need to deploy and the relationships between them. It lets you declaratively declare the dependency. So when we can build a plan around all the things you're building, and also it lets you do these higher level abstractions, which gives you a lot of flexibility. And so that's why we chose Tosca. And why GitOps? And well, what is GitOps? So very, very briefly, the core concept of GitOps is obviously it's an approach to DevOps where seeing a question here. What do you mean by using low code term? Someone's well, I'll get to that. So we'll get to that. That's towards the end of the presentation. I'm going to give you a sneak peek of what we're building, which is low code, which means you don't have to write a bunch of DevOps code and understand these DevOps systems. And we'll see how we're trying to make this easier. So I'll get to that in a second. Thank you for the question. So GitOps, the concept of GitOps is to have the DevOps processes where you're using Git as one primarily the single source of truth. So you check in your configuration code, your you could application code. The code obviously lives in Git too, and your infrastructure as code, like your Terraform modules, all that can stay in Git. And then by using Git, you could have developer-focused and developer-friendly workflows for doing the change management. So it really integrates well with the idea of continuous integration and continuous deployment, with the idea where if developers make a change, we can automatically deploy it into staging, testing, and then production. And so by using Git for that, it works well with the developers because they're already using Git. And then of course, having a single source of truth just makes everything a lot more easy to manage. And so that's why GitOps has really started to catch on as a way to do DevOps. But GitOps is pretty much for most only bigger organizations are implementing GitOps, and it's almost exclusively used. I mean, the tools out there, the public tools out there are almost exclusively around Kubernetes, which is great if you're a big organization committed to Kubernetes. But we want to use GitOps for a wide variety of things. And so Unfurl really takes GitOps to the next level, and then it basically stores everything inside Git. So it stores a configuration. It has secret management integration, so you could encrypt your secrets into your Git repository, or you could use a secrets manager. It can manage the code dependency. So if you are using, obviously, if your applications depend on code, so and that's also in a separate Git repositories. We can track the relationship between your code Git repositories and your Unfurl Git repositories. We can track the container, like when you build a container image, it has a unique digest, so we can track all these dependencies in there, and then similarly to track the software version. So by using TOSCA support for artifacts, we can extend. We could actually, also keep the version, so we can reproducibly create your development environment by storing all that information in Git too. And then finally, we actually store the deployment history. So unlike tools like, say, Terraform, where the deployment history, the state file that you created after you deploy is managed outside that using a variety of different ways, depending on your infrastructure, we're actually storing that in Git too. So we were using Git for everything. And what does it give us, and why do we want to do that? So it gives you a bunch of stuff. One, it's decentralized. So Unfurl, there's no server or agent. It's just a command line tool. So it's really easy to work with, both individually as a developer or as in whatever CI/CD pipeline you have. So it's not tied to particular implementations like Jenkins or GitLab CI or Circle CI. And so it could just run inside those. And because we're using Git, and it's developer friendly. And also I'll show you this when we do the demo, we designed it in such a way so that unlike Terraform state files with these opaque blocks that if you touch them and try to edit them, you'll break stuff quite easily. These are source code files that are able to, you can actually interact with in a developer friendly way, where you can debug it, you can make changes if something doesn't work. It's open code. So that's one of the big approaches to what we're taking. And then two, and this is where TOSCA really shines, it's designed to be high level application centric. So you can design your relationships. Oh, I need a compute instance. I need a C Postgres database. I need this kind of network, without actually tying that to a particular implementation. And then when you go to deploy, we can choose the right implementation, or you can configure it. So you have this higher level way of representing your infrastructure. And then finally, I mentioned secrets management, which is also obviously very important. If you're storing everything in Git, you have to be careful. You don't want to store secrets. And then also, and again, this is also a benefit of TOSCA. It supports day 2 operations. So in addition to just the deployment, you can define your own workflows. You can find your own operations in TOSCA, and then it'll implement and deploys those, and you can build your own custom workflows like backing up or restoring your data. And then another big part is this idea of creating isolated environments. Because we have all the information is stored in Git, we can generate an isolated environment both locally for like a developer environment, or if we want to create a container. So we can create these isolated environments, and we can actually, and I can show you in the demo, we actually can bootstrap your own. Unfurl can bootstrap itself, where it will download and install its own dependencies by modeling your development environment, just like you're modeling your cloud environment. So that's a unique way to really ease the ability to set up developer environments for developers to manage all the dependencies they have, and then also, you know, guarantee that when you have a reproducible build. And then finally, and this is another really big thing, and it goes back to this bigger vision we talked about. You know, one of our ideas is not to have lock-in. So have cloud independence. If I want to try a new service that meets the criteria for my cloud infrastructure, I can easily migrate to that. Again, everything's stored in Git. So it's Git, you can clone it. It's a essentially decentralized store. And then of course, Unfurl and everything we do here at One Commons is open source. So no lock-in is a really crucial part of our vision. And so I'm going to jump into a demo in a second, but just the top level picture, we kind of talked about this, but just to work through the flow. So the sort of process for using Unfurl is first you describe your development environment. So you describe all these things we talked about that you store in Git, like what are the repositories I depend on, whether it's a container registry for the images or other Git repositories for source code. What are all the different accounts and the account configurations that you have to keep track of. You organize that in these YAML files that sit next to essentially the TOSCA one, and then you build a model, and that's where TOSCA comes in of your environment. And then the next thing is to implement it. And so that is where you say, you know, these are the operations associated with, you know, a server. I need to create it, I need to delete it. And then you tie them in with your tools, whether it's, okay, call a command line tool, a shell script, or actually rely on, say, Terraform's lifecycle that Terraform has for things, and that'll tie directly in to your TOSCA your TOSCA models. And like I said, we integrated both Terraform and Ansible fairly deep integration. And then when you go to deploy, it will actually save the state, it'll run it and then record all that in Git. So you can do things like, for example, you can build a plan and then create a pull request for someone else in your organization to review and say, these are all the changes I'm going to make, and then commit those changes back, and then we can go and deploy it. So you can create these different workflows around that, and then it deploy. And so you can deploy it, but we notice here I say activate and manage. You can also do things like discover existing. You could say, I want to discover and capture this state of something exists. So it doesn't have to be about just deploying, you know, Unfurl doesn't have to be used as the sole source for your deployments. You can mix and match. You could have Unfurl, just like I said, record what already exists. And so that's how it works. So I'm gonna jump into a demo here. And so we'll just go into this command line tool. So let me stop. That's not jumping ahead of ourselves here. We go back to this one. And let me go. So here we're gonna, okay, hopefully everyone can share, see, hopefully it's maybe. So here, so we're in a command. We're in a we're gonna get really geeky now and jump right into so Unfurl is a tool. So I'll just type it in. So I can go Unfurl help and see all the commands. And if you are familiar with Unfurl, with Git rather, you can see it. Well, okay, you can see it's sort of like it has a bunch of the commands that are like Git, where you can say like init to create a new project or repository. You can clone existing project or repository. You can get the status on it. So those come, and you can commit your changes. So that is much is like Git. And then if you see, there's some commands here that are kind of like Terraform, where I can say, show me a plan of what's going to be that we want to deploy. I can, actually go and deploy it. I could do discover, which is kind of like Terraform's import command, even though it's a higher level than Terraform's, but it's a similar concept. And then you could, undeploy, remove, which you did. And then you can also invoke custom workflows, like stop and start to start things. So you see, it's a mix. So to kind of really show, I think, the power of what we can do is we can create these repositories that represent infrastructure and just clone it, just like I can clone a Git, just like I can clone a Git repository. And under the covers, it is a Git repository. So for example, here, I'm going to do this, and I'm going to cheat a little bit so I can make sure that I type it all in right. So let's call this TOSCA. So let me just show you. So this, you see here, we're going to do git clone one common unfurl example. So maybe since we are sharing the whole screen, I could just go here. So I happen to type this in. So basically, this is a Git repository. It has these unfurl files that basically represent the things you need. Like, I don't know. No. So you can click on it. It has these different things: your compute instance, a container service. I'm jumping ahead of myself, but so it has all these files. So what I'm going to do now, and so what this particular example does is it will take a container that you specify, and it will deploy it onto a generic cloud instance. So it depends on how you configured it, whether you're using AWS or whether you're using GCP. It will just deploy that, and I'll show you in a second. It can do it at a very high level, and then, well, this particular example does a bunch of things that you need to have a running useful web server, which is deploy SSL certificates and connect it to your DNS provider. So what I'm going to do here is just go ahead and clone this this unfurl Git repository into a new local Git unfurl repository. We'll call it TOSCA, and I'm going to press return. And so here it is. So you can see it's it just cloned it, and it gave me some messages. So I'm going to go cd into this directory. And so let's go look at what it just did. So I'm going to open up text editor here. And so what it did, so it cloned this repository, which is a template, which is a specification of all the things you need to do. And it created what we call an ensemble. So an ensemble is Unfurl's concept of a complete reproducible cloud infrastructure, what we call an open cloud service. So here it is. So it clones it. So basically it's importing the template. And then there are a few inputs that we need to input that are unique to this particular deployment that we're going to make. So we have to edit this. So I'm going to edit this. I'm just going to change this to one commons. Let's call this TOSCA at onecommons.net. And then we need an email address for basically just for Let's Encrypt. onecommons.org. And then we're just, it's going to be really boring. We'll just, this is the very, very basic Nginx web server, a container image that I put in here for demo. And then, so let's save this. Okay. And then I'll just show you a little bit about what I started to show over there on GitHub. So basically this is TOSCA. So here's a TOSCA service template. It imports a bunch of additional service templates, and this is actually this is actually an extension to TOSCA where we can conditionally import different files based on your cloud provider that's configured in your Unfurl project. our Unfurl project, we set up, this is set up ahead of time to use AWS. So because this connection is a TOSCA relationship, and that tells us that we're connecting to an AWS account. And so our template can know that and load the right types. And so, but here is an abstract level of so here's where it's abstract. So the user is typing these very high level things. So the user, and we have pre-filled this out here for the example. These are just obviously high level things that any compute instance, whether it's a Kubernetes pod that you're instantiating, an AW, your cloud provider, AWS, Google, and then under the covers inside our implementations that are in this cloud directory here, we figure out exactly what instance type that best matches these things. We configure all the details of provisioning. And of course, this is all in Tosca, so you can change this. You can build, as long as you're implementing its interface. Same thing here. This is actually what's configuring this. This configures the image that gets run on there, and so that's using under the covers. Again, is all about this is the beauty of Tosca, is that you can hide all this from the user. And here we're creating a DNS zone based on obviously the user's DNS, the domain that they just typed in. Again, it's using AWS here. So one thing, we can note, I guess, to show you, since we're going to the guts here, we extend Tosca. We didn't really extend the Tosca. We overlay on Tosca a templating language so that we can actually navigate and do a lot more deeper logic around how these things connect together. Okay, so let me just go, and then the final, and it'll write out the URL that we just built. So I'm going to go and now let us, so unfurl plan. So the first thing we'll do is type in unfurl plan. So this will show us generate a plan based on what we need. And so it's showing us what we're going to do. When we have to get a boot image to figure out, so basically we're starting from scratch. So it has to get some metadata, this kind of details here, and then finally create the compute instance, and then that's done. It'll create the DNS. And so one nice thing about this is, it'll actually generate a file called this direct here. Let's move to this really quickly. It'll actually create, and you can see in here, well, it basically creates the Terraform files. In this case, we're using Terraform that you need to, the plan that it needs to execute. And so you can review that and decide it looks the way you expect. It's not doing anything unexpected, but we're just going to go ahead and type in unfurl deploy. Oops, actually, unfurl deploy, and it's going to deploy this ensemble we created, and it's doing it. And here, now it's going to create it. So ask me, proceed to this job. We're going to say yes, and hope it works. And then, so now again, the implementations are Terraform mostly. So it's going to do a bunch of stuff with Terraform and knows all the dependencies. So it's going to download the plugins and run that. And let's see, maybe while it's talking, let me go back to our presentation. Wait, where is our presentation? Here. So, okay, and hopefully it'll be done. It's actually pretty fast. So yeah, so we just talked about this. You saw what we're doing. It's deploying, it's executing the plan, and then it's going to record the results and commit it back into Git. I could have showed you that what we just did actually is a Git repository. And then these are the different aspects of that YAML file we were looking at. And so there's a context which describes the environment, which is what I showed you when we saw the that I was connecting to a AWS environment. The spec, which is the Tosca part. And then after it runs, we'll see two new sections, the status and the lock. So the status is the status records did the instances succeed, what state they're in, and where they're created, all the attributes are retrieved, like their cloud IDs, et cetera. And then the lock is what I was saying, this precise digest of the artifacts and the repositories that are used, so we can have reproducibility. So we can jump into this, but let me just check because I'm curious. Did it work? Oh, it actually worked. Okay, so so there it is. So this, so the next step is, so it basically deployed an instance, and so inside that instance, it will be so the instance has to provision the certificate and the DNS for that to work. So that takes another minute or two, but let's see if it works. Let's see if we're lucky. Let's see how fast this is. No, okay. We'll come back to it in a second, and I'll go on. So anyway, so organize your deployment environments. So we talked about this a little bit. The spec is Tosca. We're all familiar with Tosca, so I'll jump ahead to that. And then this is what I was saying, how we basically create these deployment templates based on these higher level things, and that's what we're showing. So you can combine and combat. So if I want to switch out, as long as those high level, there's implementations for those high level interfaces, we can deploy the right ones. And so, and that's what we're showing here. We're connecting to, well, we're not connecting to the database in this example, but we're connecting to an instance and a DNS service like over here. And then this is actually taken from, modified from the Tosca presentation. This kind of shows how Tosca really shines to provide this high level matching and optimization around these high level requirements and selecting the right ones. And that's why we're using Tosca. And then again, this shows you the lock section. And then now let's try refreshing. So work by now, should have, I hope. Yay, there it is, Nginx. And so there it is. It provisions a certificate. It downloaded and installed the container, and now we're running a very, 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 very simple web server that's just telling you its server address. But there you go. So so let me go back to the presentation, yeah, and so like I said, it shows you, it records all the versions that are running, the repository, the revision IDs, and the goal behind that is to have reproducible ensembles. And so the high level concept, and like I said, goes back to this bigger vision of if you could have transparent and reproducible ensembles. So with builds, there's this idea of having reproducible builds where if everyone has a source code and a deterministic build process, I can have this assurance that this binary file is built with this source code that is open, and we all agree is hopefully doesn't have malware or whatever in it. And so so you can have these reproducible builds. And so we want to take that same concept to these open cloud services. And so if you start with these reproducible artifacts that you can build, and then you have an isolated deployment environment, and then you have a deterministic process by, like I said, recording exactly all the things we did. Now we could have, and then we deploy it into an isolated cloud environment. And then there's a lot of really interesting technology about how you can do like remote attestation, these secure confidential computing workloads that Amazon and Google are starting to offer. You can actually have this assurance that we know exactly what's running on this particular service that you're connecting to. And so now, of course, any cloud service is fundamentally non-deterministic. So it's always around some set of criteria that we care about, but we can be assured that the workload running is exactly what we're looking at. And that's how you can start to build decentralized open source ecosystem, which is again our big vision. And then, so finally, to answer the very first question is like, what do we mean by low code? So, well, one thing that gives us is if we can have these isolate these reproduce environments that are well defined, and we have a nice level of abstraction around these things, we can actually start building we can start building these components that are easy to use. It doesn't require you to know a lot about DevOps or know a lot about a complicated system that has all these issues, and you have to dig down to 5 different layers of, like, you know, what people call YAML hell or configuration hell, and sort that out. If we could build a system like that. And so what we're building is a cloud platform, a SaaS service for people to deploy these ensembles that, like I just showed you, like we just cloned. And so I'm going to show you a very sneak peek. This is under development, and it's, you know, this is not, but and I'm going to switch that right now, and I'm going to hope this all works, because, like I said, this is very, very rough and early, but we've been working on this hard. So here is oops, so let's go start here. So here is Unfurl Cloud. So this is our service. So again, it's using Git under the cover. So everything here is Git. So I'm going to click. So, but we're building these we call application blueprints, which are ensembles just like the one I just showed you under the covers, and building it so that it's really easy to use. So I'll start out here. So I just going to click on, so apostrophe CMS, for example, is a popular headless content management system based on Node.js. And it has, you know, if you go to their open source page on GitHub, it has a whole long set of instructions on how to set it up. But fundamentally, you know, it needs to deploy it onto a computer. It uses Mongo, so you need to deploy a Mongo database. Obviously, it's going to need to talk to DNS, and it optionally uses a mail server. And then so you have these basic inputs, and again, this is all very rough. So, but basically, you have to you know, give it the domain name you want, and then it has some outputs. After it deploys, it will give you a initial login password for you to do initial configuration. And so the user, whether it's, say, an open source project like Apostrophe, can write these very high level, like I just showed you in the demo, descriptions of those needs, and we're starting to build a library of these different kinds of components. And then we'll go ahead and generate these, what we call deployment blueprints for a particular platform. So it could just be a simple, you can run it on a cloud platform. We'll you know, build these in, you know, just regular virtual machines. You can deploy onto Kubernetes. You can do self-hosted if you want. And so I'm going to just press the deploy button here. I'm going to select the environment. And I'm going to actually see if this works. Create a new environment because, well, it's testing GCP because this is kind of cool. So I'm going to choose a Google Cloud platform, and we're going to go here to, let's choose me. So now, because, well, so basically, because we're using Google's OAuth flow, the user just has to give permission, and we will go and retrieve it. So it makes it really, really easy to set up. So like here, I can choose a project. I already have, save this. So now it created that environment. So now it goes back here. So now we're going to deploy to there. And hold on, why did that happen? All right, maybe I will try it this way. I think, okay, so let's try this one. There we go. Okay, so here it is. So these are the top level requirements. This is the app. It's a mean stack, which stands for Mongo, Express, and Node. And since that's what Apostrophe is built with. And so now we can just start connecting. So we're connecting to Google. So we'll choose to create a GCP instance. So again, it's just same. This is using the exact same thing we saw in the demo. So it's the same component. So all I need to do is type in these high level components, 200 gigabytes, and now it's green, and then I can do the same thing with the DNS. So we're just going to connect to Google's DNS provider in this scenario. I think we could leave that out since we already, oh, do we know? Well, I think we just, there we go. And then we can go to so here's one thing. So again, this is the power of using Tosca. So again, this is all Tosca underneath the covers. We're loading in the YAML. We're generating this UI. It's generated from the Tosca. So here, but here's the idea. So I can run my own MongoDB, or I might want to not want to do that and use Mongo has their own Atlas SaaS service. So from the point of view of deployment, it doesn't matter. You know, it just knows it wants a Mongo database. So we're going to choose Atlas, and we do that. All we need to do is type in our login credentials, because and then finally the mail server. So SendGrid. So SendGrid, again, this is the beauty of Tosca is, and the beauty of using Git and an open system is you know, we can create different components. So SendGrid's a popular mailing service, and so we can create that. And let's see, what do they have to fill? Oh, they have a lot of things to fill out here. I'm just gonna pretend my okay. Is a token. I don't think we need this. Anyways, so it's all green. So now we turned everything's green. So that means we're ready to deploy. And so now we're going to press the deploy button, and this is going to generate that plan we just saw in the demo, and it's going to trigger it, and it's going to flow. It's going to actually build this thing where it's, oops, it hasn't started yet. It's starting. So yeah. So I'm going to skip ahead. So I'm going to show you the dashboard. So so we've already deployed this, luckily. So while it's deploying. So this is our dashboard. We can see the environments we just created. We created that one just now and that one earlier. We can see all the deployments we have. So we can see these are the different items we're just looking at. The Atlas service is deployed here, and then I'll click on this. This is one we deployed earlier. It will go, and so there it is. So now we're running. This is the apostrophe demo site, talking to Mode, to Node.js on Atlas, and there it is. And so that is kind of what we're working on to make to answer the very first question in QA, which is this is what we call low code, and that's the answer to that. And so let me go back to the presentation. I think we're about done here, but I have to find the right tab. Press the slideshow again. All right, so there's our sneak peek. Come on, Google. There we go. And that's it. So I think this is the final slide. So yeah, so this is our vision. So going back to all the stuff, we're building all this stuff, is this vision is like, what if in the same way, like anyone could take open source code and they can clone it and modify it and build on top of it, and it's freely available. And that's makes open source so great. What if we could do the same thing with like live running services? I can look at a website that's an open cloud service and be like, oh, that's cool. I like the way it works. I want to change it and clone the data, clone the code, modify it, and then maybe add a feature, and then someone else can come along and pull in that feature and bring it back and do the same things that you can do with open source, but actually with cloud services. And then we could end up having a world where we have all these rich ecosystem of cloud services instead of having just a few really big kind of corporations that end up dominating the cloud space. And that's again our big vision. And that's it. Thank you. So again, you can go to unfurl.run. You can go to unfurl.cloud and sign up for the private beta. And of course, you can go to our GitHub page and get the code and install it. And so I think with that, I will stop. So should I stop sharing?
Fantastic. Adam, thank you so much. That was really good. I mean, even I understood it. You were so complete in your explanation. I love the demo. No, that was great. So you answered the low code term, and then we've got another question. Are deployment blueprints cross-cloud provider? So am I able to deploy some components on AWS and some on GCP inside the same application blueprint?
Yes, obviously that's more complicated. So the deployment, so if you think of it as so the application blueprints, the high level abstract vision of the components, and the deployments are the ones that, again, like we generate based on different implementations. So you could create a deployment blueprint that is like half, well, the common scenario, and this is a real scenario, is like DNS. I use AWS for all my DNS, and it's all in one place. So even though I might be using Google, I still want to use connected DCP. So yeah, you can mix and match those. And another thing that I didn't show you, well, I kind of showed you, notice I was creating some things and some things I'm connecting to. So in my environment, I could create instances that are shared across the application blueprints and deployment. So if I created a resource that lives in AWS, I can connect to it in, say, a GCP blueprint. So yeah, we want to support that. And then obviously it is still really new. Down the line, what we wanted, the thing that we're really excited about, and people are really excited about, is the idea of being able to migrate. Say you want to try a new service. Usually it's like, you don't want to do it because you're afraid you're going to break something or something. And here we want to, because we have these high level abstractions, we can actually do the migration process and or clone it. And so those are some of the kinds of things we want to build in the future. But yeah, hopefully that answers the question.
Terrific, thank you. I think that's, oh, actually, we do have a few more questions, more overarching. Just if you can talk about, you've kind of covered a lot of this. Just, if you had a lot of issues with TOSCA, what some of those were.
Well, I think if you notice, I mean, you probably noticed a little bit, there are things in that YAML file that are extensions of TOSCA. I mean, primarily, so there is a graph, a graph transversal syntax we use. So TOSCA does have some limitations in terms of, like, I need to, kind of navigate to find the right data that I need. And so that is, so that is an extension, and then having to layer on templating is also something that was hard with TOSCA. I think the philosophy with Unfurl is trying to be kind of incremental, and so it's important to have fallbacks. Well, you want everything to be declarative and well specified and everything, but reality is life's messy. And so that was also a challenge of figuring out how to find those points where you can drop down and get messy when you need to. I have a slide on extensions to TOSCA. I did, but I don't know if we have time for that, but I could jump. It's in the appendix slides. But I see there's another question just came up.
Yes, indeed.
I change an existing workflow? Yeah, so one of the important aspects of building Unfurl is, like a build system, figuring out what's changed and only making incremental changes, and figuring out the semantics around that was one of the a big amount of the engineering effort, was figuring out what are a set of semantics around those kind of changes that we could use and generalize in terms that you have a bunch of components and you don't want to change one and break everything else. And so how do you express that? And so yeah, so the example is, yes, you can. Obviously, if you ever use something like Terraform or something, that even a sophisticated system can run into a lot of challenges around that. But yes, it's fundamentally designed to do that like a build system, figure out what's changed and only make those changes. You can also create your own workflow. So we support the Tosca workflow syntax, so you can, have different workflows and just call them on the command line. Like I said, backup and restore is the one that we have to, that we use. It's a classic, additional day 2 workflow. Yeah.
Great. Okay. So, we're getting close. At this point, I'd like to turn it over to Chris to make some closing remarks.
Yes, thank you very much. And again, Adam, I want to echo the sentiment expressed before. This was a really excellent and very informative presentation. So thank you very much. And just to pick up on a comment you made, life is messy. So I think the reason we're having these presentations and this webinar series, we're trying to expose different use cases on different application domains for Tosca and illustrate to the community that there are a wide variety of application domains that each may come with their own unique requirements that illustrate where things get messy, and things get messy in different places depending on what you're trying to do. And we're trying to learn from that experience to see if perhaps we can clean some things up, either introduce extensions to the language or adopt best practices and design patterns to sort of get around or deal with those areas where things get messy and avoid the messiness in the long term. So these types of things are extremely valuable to help us improve the standards, improve the specification. And I welcome anybody who's got experience with Tosca, who has an implementation, who uses Tosca for a specific application domain. I invite everybody to join the TC, help out, and work with us to make the specification as good as it can be. As Adam said, I think in the industry there's really nothing for the types of things we're trying to do, where we're trying to automate lifecycle management of services in a variety of application domains. There really isn't anything like Tosca, and Tosca is really your only choice for doing those kinds of things. So our goal is to make Tosca the best platform for supporting these types of activities. So again, thanks very much, Adam. We'll continue this webinar series. If people have ideas and want to volunteer to present, please let me know, and we'll keep you informed on the mailing lists and the LinkedIn groups as to what our schedule is going forward.
And there's one more question. Should I answer that before?
Absolutely, yes. We have a couple more minutes.
So the chat question is asking about Tosca is not part of the cloud native something foundation, cloud native. I don't know what this other C stands for, but the cloud native foundation. And so the question is, why is that? And then also think about, I'm reading the question, Flux and Argo CD. So I touched on in the GitOps approach, is that in contradiction with low code. So I touched upon this a little bit earlier. So one, Flux CD, Argo CD, and indeed the entire ecosystem of cloud native foundation tools are all built around Kubernetes as a core. And so, and that's great. So Unfurl Cloud is running on Kubernetes. I've used Kubernetes for years. I'm a big fan of it. But for smaller companies, for small individual projects, Kubernetes is a huge complexity thing to take on top of, and also Tosca is broader than Kubernetes. So Tosca is very it's probably most used in the telco space, and so the telco space, they have to configure and run a whole bunch of things that are outside of Kubernetes. Kubernetes also, if you want to do something on bare metal, there's a whole layer underneath Kubernetes that you have to worry about. So we want to build something generic. And then the other question is the low code approach in contradiction with the GitOps approach? Again, there's a little bit talked about that too. Yes, it's in contradiction if your idea of GitOps is Argo CD, a big platform engineering in the company, all this big platform engineering running on top of Kubernetes. That's a lot of complexity. only bigger organizations that usually have a dedicated platform engineer building that stuff out. So what Unfurl is doing is taking the same thing with GitOps, just the concept. Let's store everything in Git. Let's keep a history of what I did so I can go back and replay it, and using it for a much more simpler approach. But I think fundamentally, if you could encapsulate things in a reproducible manner, that enables low code, because that enables you to hide the complexity. If you can hide the, you need high code, or whatever you want to call it, the opposite of low code, when there's all this complexity and the engineer has to understand all these things and configure a million things, switches and knobs, and figure out why something didn't work. That's when you need code and you need an engineer. So if you can encapsulate all this stuff into, okay, I just deployed this thing, I don't have to look inside it, it's a black box, we have a high level of abstraction, that's how you can get to low code. And so that's why we're taking this GitOps approach to enable low code. All right, I think.
Thanks for expanding on that. That's a very good point. I think we're just about out of time, so thanks everyone for attending, and look forward to seeing people at our next edition. Thank you very much.
Thank you.
Great job, Adam.
Thank you. Appreciate it. Thank you for inviting me. It's exciting to be here.